In this problem, we're going to throw a rock, so straight up into the air at 15 meters per second. For this whole freefall chapter, we're just going straight up or straight down, or a combination of the two. So the rock's going to go up with an initial velocity of 15 meters per second. So that's still our VI, that's our initial speed. It's up, so it's positive. From a 10-meter high cliff. So when this rock is thrown, it's 10 meters above the ground. So we got dy is 10 meters. Now, because it's going to fall, it's a displacement, it's going to end up further down from where it started. Then that's going to be a negative 10. We threw this up, so 15, so I already said that's a positive. I'll just mark it though. And now it wants to know what does it want to know? Calculate the speed of the rock as it hits the ground. That's VF. It is not the speed after it hits the ground. After it hits the ground, it's obviously going to come to a stop. It wants to know the speed as it's about to hit the ground. So that last split second right before it hits. Because it's thrown up in the air, and gravity's affecting it, we know the acceleration. So we're going to call A little g, the acceleration due to gravity, which we know is a negative 9.8, and then that's meters per second squared. So we can check units, meters, 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 seconds, seconds, so we don't have to convert anything. We just need to figure out, just like we did with the acceleration, what are we missing? We are missing time. So there is no mention of time here. So we want to use an equation that doesn't have time. You could use one of the equations to find time and then do another one to get VF, but that's extra work that you do not have to do. So I'm going to move this out of the way. And we're going to use, so the equation that doesn't have time in it is the VF squared equals VI squared plus 2g dy. Now I forgot to mention, with the other equation, with the original equation, g was a, so I changed the a to a little g just to represent gravity. And then d, the displacement, I added the subscript y just to remind myself that it's up and down. You do not need to put the subscript in right now. We're only looking at stuff going up and down. So you can assume that d is a vertical. But just out of habit, I throw in the subscript y. We'll do more with that later. Variable y, I'm sorry, we got the variables. We're going to plug those numbers that we put in for the variables into the equation now. Again, no math. You're just going to plug in the numbers. VF squared, or the VF is what we're looking for, so you leave that alone. Don't drop off the squared. Keep that there for now. VI squared, you're going to do 15 squared. Again, don't do any math here. Don't type in 15 squared in the calc. Just write what you know VI is. 15 plus 2 times, that's a negative 9.8. That's awful. Times dy. And then you're going to do a little algebra here. And solve for VF squared, which this is pretty straightforward. Oh, we know dy. Sorry. Dy is a negative 10. Let me fix that. Wasn't paying attention. So we got a negative 10 here. So what we end up with is a negative times a negative is going to give us a positive. So 2 times 9.8 times 10 plus the 15 squared is going to be equal to VF squared. And then we just take the square root of that. And we're going to get VF is 21 meters per second. Now just be careful here. If I would have left off the negative, because it fell 10 meters, it didn't go up into the air 10 meters. It started at the top of the cliff, and ultimately it did go up some. We don't know how high it went. But regardless, though, its displacement is the straight line from where it started to where it's finished. So in that aspect, it fell 10 meters, which is why we had to make the 10 negative. If you leave the 10 positive, then you're calculating how fast it would be going 10 meters above you instead of 10 meters below you. And then if you left off the negative 9.8, that would also mess up the math, because we need those negatives to cancel out for this one to work out right.